Hi, geometry kiddos. It's Mrs. Grafe.
And I'm Mr. Kavik.
You guys know us, or maybe you don't know us, but now you do. Today you do. We are the the eighth grade teachers of geometry. So we're coming to you today with a video that we would usually have you do this work to understand what you need to about the height in a triangle. So hopefully you just did problem 286. Where you were reading about, hey, where should we draw the heights? And hopefully you realized if I'm going to use 6 inches as my base, then I'm going to need to make let me get this here, a perpendicular line to 6 inches. If I use the 5.5 inches, then I'm going to need to make a perpendicular line going up to the vertex of that side and so on. So we want to help you get a better understanding. And hopefully you understood 286, and I'm going to let Mr. Kavik take it over for a moment.
Okay, so we are going to be looking at the height lab in 287. So what we would like you to do is pause this video right now and read over the height lab and see what they're asking you for.
All right, so hopefully you're done reading. I'm going to bring you in a little closer to the action, because we got some string going on here that usually you would do. And I just want to see, let's see if this comes up on video. We have string to create what you just read. Oh, we're going to get you a little closer. Okay, hopefully, okay. Oh, I think you can hopefully see a little bit of the string. Should we get closer? What should we do, Mr. Kavik? All right, so hopefully you can see the string here. Let's pause it. I'm going to see. All right, so kiddos, we're problem solvers. We're figuring things out here. So hopefully, yep, we think you can see this a little better. So as you read through 87, here is our base down here. Hopefully you can see it's taped. It has 2 end tapes. Here are different sides of the triangle. And then what we have here, what do you think we have here, Mr. Kavik?
That looks like a height because it's straight up and down.
Ooh, it is, what's the key word? Perpendicular. Woo, nice work. Perpendicular to the base. So as it mentions here in part B of 287, we are going to do 1, the height of the triangle is inside. Hopefully you're seeing that here. 2, the height of the triangle is a side. And if, yep. So here we go. The string is part of the side. We would have you do this in a normal year. And
So,
Mr. Kavik?
what type of triangle is this?
Ooh, this has a nice right angle, so we call this a right triangle. I don't think it's isosceles.
No.
Nope.
May or may not be. We don't know.
Yeah, but we could use the Pythagorean theorem on it.
Yes, to figure that out.
And then the third scenario is the height of the triangle. Do you want to go your way or my way? Outside, outside of the figure. And you'd pretend that this is dashed. And here is that height up to the top vertex from the base.
Yes.
Now, a couple of you guys last week added this on to the base length. We would not add on that extra length. You would only use this base times the height divided by 2. Anything to add, Mr. Kavik?
Just remember, you can have a height inside the triangle, like so. Part of the triangle, when it's a right triangle, it's a side. Or most likely when it's, oops,
We lost the side. Hold up, we'll make shift.
maybe we'll go your way.
Okay.
When it's an obtuse triangle, a lot of times you have a height outside. So, and remember, as Miss Grafe said, the distance between the base and the height
There we go. Yep.
is not part of the base. That's part of the triangle that does not exist. So hopefully this helps you out by showing you where the different heights can be. And never, ever use a slanted side as a height.
And now you guys are going to work on, very nice, Mr. Kavik, you're going to work on 288 to practice drawing in various heights. We're going to give you index cards so you can possibly do that on paper, or you're going to do your best to do it on
a PDF that we send you.
Yeah.
So.
All right, guys, thanks for
See
tuning
ya.
in. See ya.